How does our body break down food? It uses the digestive system. A group of organs in our body breaks down food into smaller components until it gets absorbed by our body and turns into energy. However, our digestive systems are in our body. Thus, I will be creating an animation to show the process of digestion in our body and what happens after we swallow our food. Using an online coding program called Scratch, it will allow me to learn and create my own program and turn it into animation. Coding allows us to apply systems thinking and design processes to produce a solution, which is why I chose Scratch for my maker project. It is a computer-based product that allows us to learn through play while learning, all by using technology. The Maker project links to Acara Digital Technologies strand in digital technologies, processes, and production skills. The description is to collect, explore, and sort data and use digital systems to present the data creatively. The elaboration is using digital systems to organize data to improve meaning, for example, using word processing software to create a list of tasks or visualization software to create a mind map, showing relationships between characters in a story. In our Maker project, we will be using the software of Scratch to create a visualization of the digestive system. On to our project. The digestive system consists of our organs working in unison to fulfill digestion and provide us nutrients and energy to help us stay alive, build our tissues, and grow. This is the research I conducted before beginning my Scratch project. In order to create my project, I first learn and understand the functions on Scratch through a tutorial called Getting Started. Here, I watch the tutorial and begin by learning how to move my character, how to make it play a sound, and how to comment my animation to begin using the green flag. Then, I move on to watching other tutorials, such as how to animate your character. This tutorial teaches me how to change the costume of the character to make it look like it is moving and also make it say words and play sounds at the same time. These are some examples of tutorials I watched in order to learn the functions of the blocks and how to apply them in my own animation. Different tutorials provide guidance for specific programs we aim to create. After watching and learning from the tutorials, I begin to create my animation. First, I begin by choosing a character. I then begin by adding blocks in order to create text bubbles for what my character will say throughout the digestive process. It is important to create both speech text and also blocks that she did not say anything, in order to give it time before the next organ is reached. Thus, I use the same timing for each blocks. Then, I move on to choosing a food product. I picked a donut and began to input blocks to create movement, as well as text blocks throughout the digestion process. My donut says, "Where are we when they reach the next organ?" Here, I began to meet with some challenges. My character and donut were not in sync. They moved and spoke at different timings, and I had to find a way to coordinate this. Thus, I realized I should try changing my timings for one character and decided to slow down the movement of the donut. Once I edited the timing of the movement of the donut and slowed down the gliding to the next organ one at a time, and I ensured that every step is synchronized. Finally, I was able to coordinate the words and movement, and my animation came to life. The donut asked the character where am I during the important steps of the digestive process and allows the character to explain the process of each organ it moves to. I successfully created a project where I can link the learning of science to technology through coding. What did I learn about teaching design and making through this self-defined maker project? This design-based learning activity has allowed me to implement design and technology to the daily curriculum of science and allows students to scaffold their knowledge of science concepts. It allows for the use of creativity, imagination at the same time by creating their very own animation using their own ideas. Studies find that design-based learning for science has a positive impact on students' learning. For example, there were significant improvements for students aged between 5 to 6 about water as compared to students who were taught the same concept without design-based technology. Learning. It has taught me that design-based learning allows for explicit teaching and learning.